All right, so where we're at now is we need to talk about complex designs, and these are experimental designs specifically that have more than one independent variable. So let's start out with an example of what that would look like. So let's say that we have two categorical independent variables, and let's say we're looking at something called the beer goggle effect. The beer goggle effect is when um, if someone drinks alcohol, people appear more attractive. All right. So let's say we're looking at the effect of alcohol consumption and model status on attraction. So let's practice identifying independent and dependent variables. So in that example, the effect of alcohol consumption and model status on attraction, what would the dependent variable be? And remember, the dependent variable is the outcome. Now the answer would be attraction, how attracted you are to someone. What are what is the independent or what are the independent variables? Well, the first is alcohol consumption, and the second is model status. All right. So, how could we do this experimentally? Is let's say we're going to randomly assign people to one of four conditions. All right. So, the first independent variable, people are going to either drink alcohol or not. That's the placebo group, those who don't. The second is they're going to see a picture of either an attractive person or not. So look at those two pictures below. I don't know who these people are. I just went to Google Images and typed in attractive person, and the person on my left showed up. And then I typed in unattractive, unattractive photo, and the person on the right showed up. So I don't know who these people are, but Google tells me that they are attractive or not. And then let's say for the dependent variable, what we're going to do is they're going to see these pictures and they're going to rate them on attractiveness on a scale of 1 to 5, 1 being not at all attractive and 5 being extremely attractive or something like that. All right, so what we have here is we have two independent variables, drinking or not. You have what picture you see, the attractive or not. And then the dependent variable is going to be the female rating pictures. Now let's practice with this some more. So if the beer goggle effect is true, who should be rated the most attractive? All right. Now the answer to that is going to be if you see the attractive photo while you're consuming alcohol. All right. Who's going to be the least attractive rated photo? Well, it's going to be the unattractive photo, so the bottom right, when you are sober, so you're drinking your placebo drink. Now, the main question is what's going to happen in the middle? So, for example, if you see the model, so the attractive photo when you're sober, is that going to be rated higher or lower than if you see the unattractive photo while you're drinking? And that's where this study gets really interesting. All right. Now, let's keep playing with some examples here so we can practice. What kind of experimental design do we have? It is a 2 by 2. We have two independent variables. That's why you have two numbers. Each of them have two levels, so a 2 by 2. Can we make causal claims about our findings? All right, the answer to that is yes. We have a manipulated independent variable. We actually have two of them. We have a measured dependent variable, attractiveness, and we use random assignment because I said that in the example. We use random assignment. Now, what if we found the beer goggle effect? And someone could say, well, Chris, what about the weight of the participant? How much a person weighs influences how much alcohol it takes for them to get intoxicated. So what about weight? My answer to that is what? Random assignment. Why does that matter? Because we are randomly placing people in one of these four conditions. So the effect of weight should be, at least in theory, equally distributed amongst the four conditions. So in other words, we're going to have skinny, medium-sized, and obese people in all four conditions, theoretically, if random assignment works. So that shouldn't matter. But Chris, what about tolerance? What if you have some people who drink a lot versus some people who don't drink at all? You know what I'm going to say to that? Random assignment. And that's the way these things work. All right, so let's explore the beer goggle effect. All right, so let's be clear on this. What we have is, we already practiced with this. We have four conditions. So you can see the four conditions here. We have the model and the non-model, so attractive and not. And then you have the same attractive and non-attractive photo with the alcohol present. So we have four conditions total. All right. Now, here's what we can do. Now, this is where the complex designs get tricky. All right. What we can have is what's called a main effect of attractiveness, a main effect of alcohol, and an interaction. All right. So we actually have 3 effects. So let's talk about each of them. So the main effect of attractiveness. Let's define our terms here. So let's start with main effect. All right. Main effect. Main effect means that the difference between the levels of one independent variable is statistically significant. All right, so let's do a little stats lesson real quick. So let's say we have the attractive photo and the non-attractive photo. All right, and let's say what we're going to do is we're going to have, let's say, 100 people do our study. And it doesn't matter if they drank alcohol or not. Remember, this is independent of alcohol. All right, independent. So it doesn't matter. So we're just looking at what picture did you see. And let's say that we have a mean score. Remember, it's on a scale of 1 to 5 for attractiveness. That the attractive photo was, let's say, a 4. And the non-attractive photo was a 3.99. All right, now what's going to happen is clearly if you look at those 2 means, all right, this is the average across all 100 or 50 people in this condition, 50 people in the other. What we're going to see is that we have a different set of means. So can we say that the attractive photo, people who view the attractive photo rated it as significantly more attractive than the non-attractive photo because those means are different? All right, and the answer is no, we cannot say that because, yes, even though these means are different from each other, their difference is not meaningful. And we don't know why those 2 means are different. Yes, they're different, but we don't know why. So maybe it's just that by happenstance, the people in the attractive photo condition just got lucky, and they just happened to rate the picture just a little bit more attractive than the other. Sorry. All right, but what if we have something like this? A 2. Well, now our difference is bigger, so that's a bigger effect, and remember, that's what we want. We want the bigger effect, but we still don't know if that difference is meaningful. Maybe it just so happens that the people in the non-attractive condition are just not having a good day, or there's some other random factor coming in that plays into this. All right? Even though random assignment should work that out, the issue is we don't know. And so what we're going to see a lot in the articles that we read is that whenever you see a main effect, that means, and we'll talk about what that means specifically in a second, it's going to come with the term significantly different. And it's going to have this symbol, P less than 0.05. This is a very important notation here. P, right here, that stands for it's a probability. So for the sake of this class, there's a more technical term that if you ever take a stats course, you'll learn. But for the purposes of this course, whenever we say P is less than 0.05, what we're saying is that the difference between the 4 and the 2 here in this example, the difference in the 2 means, is due to a real effect, and it's not due to chance or luck or error or something weird. It's really because of the manipulation that we did in this example. All right? So theoretically, you could have an example where you have 4 and you have 3.50 as a mean. And if it has that P less than 0.05, that means that difference is real, it is significant, and it's due to our manipulation, not due to luck or chance or outside factors. All right, so this P less than 0.05 thing is going to be important, and that's what significant means. Significant means that our effect is not due to chance or luck or error. It's actually due to our manipulation. So the word significant is going to be very, very, very important here. And so let's go back to the main effect of attractiveness. If you see a main effect of attractiveness, what that means is independent of any other independent variable. So no matter how much they drank or didn't drink, it doesn't matter. Who is going to be more attractive, the model photo or the non-model photo? And in addition to that, if it has P less than 0.05, that tells us that these means are significantly different from each other, and that those in the attractive photo were rated as more attractive than those in the non-attractive photo. And it is a real effect. All right. So that's what that means. And so whenever you have a complex design with multiple independent variables here, what we can do is we can test, number one, the main effect of attractiveness. Two, the main effect of alcohol. The main effect of alcohol would tell us, independent of what picture you saw, right, independent of what picture, does alcohol affect the ratings that you give? So no matter what picture. So let's be specific on the main effects here. The main effect is basically saying, let's just focus on one independent variable at once and ignore all the others. Now, the interaction, that's when you deal with both independent variables at the same time. Now, the word interaction, it has a specific term. It's called moderation. Moderation and interaction are going to be used interchangeably here. And my advisors in graduate school and the people who taught me statistics once told me that in social psych, if you don't have an interaction anymore, then your study is not as important as you think it is. And that's because we know that the world is a multivariate place, and the interaction takes both independent variables into account. Remember what we said about the beer goggle effect? We said that the most attractive ratings will occur when the model's attractive and you're drinking alcohol, both variables at the same time. Now, interaction, remember, it's another term for moderation. We're going to use those two terms interchangeably. It answers a specific question. It answers, for whom does the effect occur the most? So in our beer goggle example, it would be, for whom does the effect occur? And an interaction, what it answers for us is going to be, at what combination of levels of different independent variables are we working with that influence our results the most? Right? So what you guys have to understand is that we have to be able to identify these things. And remember, for every variable that you have, every independent variable, you test a main effect. If you and the interaction is going to be how many independent variables you have interacting together. All right? So if we have two independent variables, that's one interaction. Obviously, these designs get more and more complex. Let's say you have three independent variables. All right? That means you're testing the main effect of A, B, C. That's three effects right there. You're testing A times B, A times C, B times C, and the ABC interaction. All right, so let's be clear on that. So let's say you have independent variable 1, independent variable 2, independent variable 3. That's a main effect, a main effect, a main effect. But you're also testing the interaction between independent variable 1 and 2, the interaction between independent variable 1 and 3, and the interaction between independent variables 2 and 3. And now you're testing something called the three-way interaction, which is basically saying that all three variables interact together. So even, let's say hypothetically in our study, we looked at sex of participant. Now we would expect that female photos would be rated the most attractive when the male participant used the attractive photo and their drinking. So now we're dealing with three independent variables in terms of that interaction. Obviously, these things are complex, and we're going to practice identifying them in just a second.